Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to discuss a new topic in graph theory, which is handshaking lemma. Let's first read the question to understand the problem. It is possible to construct a graph with 12 vertices such that 2 of the vertices have degree 3 and the remaining vertices have degree 4. Justify. The problem statement is quite clear. We are given 12 vertices, out of which 2 of them are having basically degree 3 and the remaining vertices, that is 10 of them, are having degree 4, and we are to tell whether the graph is possible or not. So with these given constraints, whether a given graph is possible or not. Here you see that the number is quite less. I mean 12 is, though it is difficult to draw it on paper, but if suppose in real life we have a greater graph size of about, let's say 1000 or 10 raised to power 3 vertices, then it would be impossible to draw them on any sheet of paper and find out whether the graph is actually possible or not. So for that, what we have is handshaking lemma. Let's first define it. Handshaking lemma, as the definition goes, in an undirected graph. Note this, that this is defined for undirected graph. The sum of the degrees of all the vertices is equal to twice the number of edges. We'll discuss further that what is the degree of a node, and therefore the sum of all these degrees needs to be equal to thus twice of the number of edges. In this definition, let G of V comma E denote a graph with V vertices and E edges. That is, in this graph there are V vertices, the number is V, and E number of edges are present. Degree of a vertex simply means, like suppose I have a small graph here of 3 vertices and I have these 2 edges, right? So the degree of this vertex is 1 because only one edge is connected to it. Similarly, the degree of this vertex will be 2 because 2 edges are connected to it, and the degree of this vertex will be 1 again, right? So this is what degree of a vertex means. Then we have this particular expression which says summation of small v belongs to capital V. Degree of small v is equal to 2 times the number of edges. This modulus is just denoting the number of edges, so don't confuse it. So this degree is basically taken sum over all the vertices that are present in the graph. Perfect. Now we come to the next part, which is the observations in handshaking lemma. So the first observation is the total degree of all the vertices in a graph is always even. As you can imagine that the total degree according to handshaking lemma needs to be an even number, right? So that is what is written in the first observation, that the total degree of all vertices in a graph will always be even. Next, the number of vertices with an odd degree in a graph is always even. Now if we just go back to the lessons we have been taught in number theory, is that odd plus odd gives even, right? Even plus even gives even, but odd plus even will give odd, right? So as example, you can see 5 and 6, we are given 11. So let me explain it in this way. Let's say we have the number of vertices having odd degree as x. So the odd degree can be anything. Let's take it 5, and then we have, let's say, the even degree as 4, and the number of it is any number. Let's say we take it as 4 for the time. So whatever number we take in this part, it doesn't matter, the entire part will be even. But here in this part, if we take 2, then we are getting even number. Otherwise, if we take 3, we will get an odd number. So we need to make sure that this whole part becomes even. Then only we'll be following this rule and getting an even number. So that's why x needs to be an even number. Okay, so I hope this makes sense now. Let's proceed further. So the next part is the actual calculation. Number of vertices is 12. The number of vertices with odd degree is 2, which aligns with the point 2 obviously, and the last part is the number of vertices with even degree is 10, because 12 minus 2 is 10. Lastly, if we calculate the summation of the degrees of all the vertices, we will get like this, that is 2 into 3, the odd degree, plus 10 into the even degree. So if we just calculate it, you will get 6 plus 40, which is 46, which is even. Since this is even, we can surely say that it follows the handshaking lemma, and since it follows that, we are able to create a graph. Now we want to calculate what is the number of edges in that graph that we would have been drawn. So for that, what we can do is simply put 46 equals to 2 times the number of edges. So if we just calculate it in this way, we get number of edges equals 23. So that's been it. So if you are having any doubt in this question, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving. Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.